I think I need to do another introduction so that this makes sense or something. So, good evening, folks. Welcome. Thanks for coming. We're glad you're watching. Apollo. How many people have heard about Apollo? Let's start there. Okay. And how many people have used it? Like you've either played around with it or you've done some kind of thing. Cool. One person. So you are the person I'm going to ask when I don't know stuff, because I don't know that much. We do a meetup in Stockholm as well. There was a presentation about Apollo there this month, which is where I got the idea to just copy it and do this. And then there was a lot of talk about Apollo at the conference, so I learned a little bit more there. But I personally have not built anything with Apollo, so my deep technical knowledge is somewhat limited. That's probably an exaggeration. I probably don't know shit about it at a technical level. But I've read some stuff and I've talked to a lot of smarter people than me. So I'm going to talk about a couple of things and talk about first, like, what is Apollo? Just give a kind of run through. Why would you want to use it? And then a little bit about the future and where Meteor is going, or where, how does Apollo and how do they fit together with Meteor? So to start out, what is Apollo? Fundamentally, it's a GraphQL client and server. It's all about GraphQL. So how many people are familiar with GraphQL? Let's say like you've used it or something. Okay, so a couple of people. And how many people have heard of it? You have some idea of what it might be. Okay, a handful. So GraphQL is an application query language, which essentially means that when you work with Meteor typically, and you want to retrieve data, for example, on the client, you use mini Mongo. So you use like the Mongo query syntax inside your application. You can say greater $GTE for greater than or equal to, stuff like this. And GraphQL makes this kind of implementation agnostic. So it's just a plain text way of querying data. You say, this is the data I want, and you get the data back. And the interesting part about it is it's not tied to any kind of implementation. So it's just a query language. You can pass the data around in JSON. You can pass the data around through REST. You can kind of use it in any number of different ways. It's just a protocol to describe, this is how or a language to describe, this is the data I want, and then you get that data back. So here's a simple example. This is a GraphQL query. So it's fairly straightforward. It looks, it's kind of like code, right? This is in GraphQL, and then you can see there's a nested object profile picture, and then this is the response that you get back in JSON. So you can see that obviously they line up, right? You have, you specify the fields that you want, and then you get those fields back almost exactly. And that's kind of the essence of what GraphQL is. This is kind of like a very quick summary. And one of the interesting kind of features of this is that the schema, like the shape of the data that you want to retrieve, is defined on the client or by the client, right? Not by the server. And this is a fundamental shift, because typically, if you look at REST APIs, if you look at the Google Maps API, the geolocation APIs, the server determines what your response is going to look like. And then you have these things with versioning where they'll say, like, you're getting API version 1, and so on. But it's always down to the server to say, this is the data you're going to get. So you send me some parameters according to some specification I've created, and I'm going to send you something in response. Whereas with GraphQL, the client says, these are the fields I want. And the server is required to return the fields in that precise format, which is very interesting because it has all kinds of stuff about backwards compatibility. Like I was reading something about Facebook. Facebook deploy a new version of their mobile app every 2 weeks, and they guarantee to support every version in the wild for 2 years. So at any given point, they have 52 versions in the wild per platform, per environment, right? So they have a ton of versions out there. And GraphQL helps them to solve that, because if you get a GraphQL query, you don't have to care. There's no kind of versioning. You just demand data, you get exactly that data. Yeah, and so this is just the same thing again to show that in the actual request, you specify the shape of the data, and that's what you get back, right? So that's a little very kind of simple summary of GraphQL. So Apollo is really two things. It's an Apollo server and it's an Apollo client. And they're two pieces. You can use them interdependently. You can use one, both, neither. So we'll talk a little bit about the server first. So Apollo server is just a GraphQL server. You could, if you were using a different GraphQL server, you could swap it out and use Apollo instead, right? It's just a GraphQL server. Aiden, is it possible we're hearing your phone? No? Oh no. What are we hearing?
It's outside.
Oh, crazy. Okay. I have my brothers visiting, the youngest members of our team in the Superlumen shirts, representing. As you can see, they're fascinated by Meteor. Way to go, homies. Okay, and so essentially the GraphQL server, Apollo server, there's two main things. There's a bunch of other stuff, but essentially it breaks down into two different pieces. There are resolvers and there are connectors. And so resolvers first. Resolvers, as the name might suggest, are about resolution. And so this is about taking that GraphQL query and figuring out where you get the data from. So I need to get the data from here, or I'm going to get it from this collection, or whatever. And resolvers are stateless. So this is kind of important to understand when you start to get into it. So this is an example. This is the whole file, actually. So this is like a whole resolver file where you can see the APIs, and this is using the thing. But the interesting part is in the middle, where you return this, or you use this, generate this object, of which the really interesting part is this. And so this is essentially taking a GraphQL query and then resolving it from the database, right? So in Meteor, this is like author.find. You take the past name and you look up the data and then you return it, right? And so that's what this is what the resolver does. The resolver takes the query from GraphQL and maps it down to whatever back-end system you're using to store the data, right? And one of the things about Apollo server is you can use any back-end you want. You're not required to use Mongo. So, talking about the enterprise and stuff, this is kind of going in that direction. So in very high-level terms, that's what a resolver is. It's a little bit like a reducer. If you're familiar with Redux, it's kind of a similar concept. But it's not a pure, I almost wrote pure function instead of stateless, but that's not true. So connectors. Connectors are, as the name implies, about connecting. And so you can use any of these, you can use any backend you want with Apollo. And the connector is where you maintain state. So the connector is responsible for maintaining the database connection and can make changes and stuff like that, whereas the resolver is really just about this mapping part. So it's like, take this query and figure out what the corresponding query should look like for whatever backend you're using. So this is from the Apollo docs. This is an example connector. And this is just a simple example using using like a local variable in memory to store some data, right? But the interesting part is that in your resolver, now instead of doing author.find, so this is what we had before, you swap that out for context.connectors.author.get, right? And so this, now you can see the before and after, then you can have state within your connectors, right? So the author list will persist between requests and so on because it's in a connector. So that's a very sort of brief summary of Apollo and the server, and it kind of gives you the basic architectural structure. Essentially, you take GraphQL queries and you resolve those into other queries, and then you connect to databases or other systems, you retrieve data. And you can put actually anything behind Apollo server. It doesn't even have to be a database. You can put a REST endpoint, you can put an IRC bot, you can connect to external APIs, you can do almost anything. It just provides you with this framework where you create these interfaces that are ultimately end up publishing, responses to GraphQL queries. So that's a little kind of summary of the server. Now we're going to talk about the client. And so Apollo client, as a package, is a GraphQL client, right? And you can use Apollo client with any GraphQL server. So it's not necessary to use the server and the client together. And in some ways, this is one of the premises of GraphQL itself, is that you're providing the standardized interface, this application query language, that your clients can use to talk to servers, and therefore you can start to be less concerned about which, it's similar to REST, right? You can implement your REST endpoint in any server you want. You don't have to care about that when you're consuming it on the client. And if you're familiar with Relay from Facebook, Relay is similar to, or let me say, Apollo client is similar in its scope to Relay. So there are essentially two parts to the client. When you use it, practically speaking, there are two things that you use. And this all assumes that you're using React. You can also use it with Angular. I don't know anything about that, and I haven't looked into it, and I don't care, to be honest. React is the way to go. So there's two pieces to it. There's Apollo client, and there's Apollo provider. So what do they actually do? We'll start with Apollo client. So fundamentally, the Apollo client fetches data. Right? It's responsible for connecting to the server, making the request, getting that stuff, bringing it back. The provider is responsible for delivery of data. So it delivers data into your React components, right? Apollo provider is React specific. So the Apollo provider is a little bit like Meteor's create container or the connect interface from Redux, if you're familiar with either of those. It essentially takes data from the Apollo client and delivers it to your components. So there is another implementation that supports Angular, for example, but Apollo provider delivers data into your React components. So Apollo client is really where the kind of work gets done. Like Apollo provider, the provider just delivers the data. You don't really have to be too concerned about it. You hope it works, and there isn't too much to consider. So we'll talk about the client a little bit. So fundamentally, its kind of core purpose is to retrieve data from the server, right? You make some kind of request, and then it goes to the server, requests that data, and delivers it to your component. That's the sort of model. But it does more than just straightforward fetching of data. So the first thing that it does is it caches data. And so this is a little bit like Mini-Mongo in the browser, in that you have stuff there potentially before you need it, and also maybe between, if you need it only partially and then you need it again, ideally it's still locally saved in the browser. That didn't make a lot of sense, but everybody knows what caching is, I think. So it does caching is the first thing. But because of the way that GraphQL works and the fact you can specify precisely what fields you want client-side, it also does something called query diffing. And so essentially what this does is looks at what data you are requesting, looks at which pieces of that data are in your cache already, and if there's any pieces missing, like if you're missing a specific field, it constructs a new GraphQL query for just that field, goes and retrieves that, fills the hole in the cache, and then passes the data to the provider, right? And so this is in theory very slick. So there's an example in the docs. The first query is we get a to-do list. We want the title created at tasks, name and completed fields within tasks, right? Fairly straightforward. And then the second query, we want the same data, but now we want to add user, right? So we want to know in addition to the user. And this is retrieving the user with the field's name and username, right? Rather than specifying, rather than just an ID, like you would if you were just getting the raw data. And so the difference between these two is just the fact that the user is missing. And so that's the only query that Apollo client will send when you make the secondary request, right? So it figures out what you already have, figures out what you need, and then makes a request for the missing parts. And this has some obvious benefits, right? Less data over the wire, it's faster, less waiting, and if all your data is already there, you get the data right away. It also does reactive queries. Now, don't quote me on the state of this, on the status. Like, I'm not sure if this is really fully implemented and ready to use. It's in the documentation, but there was a bit of talk at the conference and in Stockholm about how some of this stuff's not ready yet and some of it's in work in progress. So, if you're watching this and it's like August or September, then this is probably ready. For the live audience, I don't know if it's ready, but that's what it's going to do. So GraphQL has support for reactive queries, whereby you can say, okay, I want to update this query, and if something changes, and Apollo's client is handling that in some way. It also provides support for mutations. So mutations are a fancy way of saying you want to change data, right? So you want to change a field, you want to insert a new record, or you want to modify an existing record. These are mutations in the GraphQL parlance. And Apollo client will handle that for you. So it gives you the interfaces to do that. It connects to the server, passes it. And related to the mutations, it also does or will do, depending on when you're watching this, optimistic UI. So this is where the change gets applied locally within your browser and then sent to the server and intelligently rolled back if the mutation fails on the server. So Meteor does this today with Mongo, and there's a bunch of ways to do it. But if you just do a simple insert in the client, it succeeds right away locally, gets shipped to the server, and then if there's any problems, gets rolled back. And so Apollo also has or will have this option. So that's a summary of like how it actually works and what it is. Any questions at this point on kind of what Apollo is? And I'm going to get into like why you might want to use it and what it does and where it's going and stuff. But any questions on the basic mechanics?
So Apollo is a totally different, I guess, product. Meteor is one thing, Apollo is another thing, or they have something in common.
So the question is about the relationship between Meteor and Apollo. We'll get onto it. It's coming. Yeah, well, I explain all that and maybe a little bit about, I'll try to predict the future. Any technical, like anything on the way that Apollo works or what it does or just the specifics of it? Steph?
Just one question. Can I deliver also media data from an Apollo server or just object strings and real images, sound?
Can I deliver media from an Apollo server? That's a great question, and I'm tempted to answer it just by making it up. The simple answer is I don't know, but I don't think so. I think Apollo is a GraphQL server, and GraphQL is about shipping objects rather than binary. That's my guess. I'm not 100% sure, but I mean, in the examples you see where you have the images, the profile picture and stuff, it's always a URL where you can get that image. So it's not a definitive, but I would say that in general, GraphQL is about delivering data, not about delivering binary. Any other technical? No. Great. Okay, so why would you want to use Apollo Stack? And there's a few things. So one of the big reasons is that you can use any database, right? If you want to use PostgreSQL with Meteor today, it's not really possible. There are packages and there are hacks and people are managing to do it and they're making it work, but you don't have first-class support. It's not built for it. Like Meteor equals Mongo. And for many use cases, that's a pretty significant limitation. If you're doing, I once built a Bitcoin payment processor on top of Meteor, and trying to get transactional guarantees in Meteor with Mongo is challenging. You have databases that just do this right out of the box, right? And there's also some interesting databases around. Like you can do some really interesting stuff with databases like Cassandra, which Apple are running, I don't know, 80,000 node clusters with petabytes of data and stuff. So if you're doing stuff that requires funkier databases or even just old school relational data, then Apollo is an alternative to. You just can't do it with Meteor. So if you're comparing the two, then that would be a big selling point. Beyond that, I mentioned earlier, it's not only specifically that you can use any database, but you can use any backend. You can use anything behind the Apollo server. Like you saw in there was in one of the examples, there was just a map, right? They created a map and they set and they inserted and they removed from the array effectively. So you can use anything. You can use variables. You can use local variables. You can also mock data, and Apollo server comes with mocks built in automatically, so it will automatically mock. It just says it works for every string field, and so you don't actually need a backend at all. Like you could just start out by building a simple GraphQL server that will return fake data. So that's a big benefit. If you're trying to use Meteor and do these kind of custom backend stuff, it can be a real headache. Whereas Apollo supports it. Another big thing that was talked about quite a lot at the conference is scale, right? And scaling is an interesting challenge. Like a lot of people are building for scale that they anticipate having, which they probabilistically are almost certainly not going to have. And in many cases, the number one rule of scalability is don't solve problems you don't have. Like wait until you have those problems before you try to fix them. But Meteor's reactivity is built on top of op-log tailing. And this is where when an operation reaches the Mongo database, it gets added to a log, which is how Mongo does replication. And so what Meteor does is just watch that log and try to figure out, was that a change that I should care about? And if it's a change that it should care about, then it kind of gets the update and pushes it out to all the clients and stuff. From a scalability point of view, this is horrific. Actually, op-log tailing specifically is not necessarily the problem. And there was a bit of talk about it at the conference, but it does not scale linearly. This is the fundamental problem. So you cannot, if you have 50 clients listening for 50 different queries on the one server, then that is not 10 times as much work as having 5 clients. And it's to do with the merge box and stuff. Long story short, it doesn't scale. It's fine, in the early stages, and like I said, the number one rule is don't solve problems you don't have. But there are people regulars here at the Meetup who are hitting problems where their applications are reaching the point where they can no longer run it on one server, and then it gets difficult to split it onto multiple servers, or it doesn't always help your load significantly, and so on. So op-log tailing doesn't scale. And then GraphQL. I mean, GraphQL in and of itself is a pretty compelling reason to use Apollo, in the sense that GraphQL as an approach, as a practice, is a pretty interesting step forward. It's a little bit like moving from, the frameworks of old to something like React, or there's a sort of evolutionary step forward. And GraphQL, I think, is that, and it's becoming that, and it's also becoming more of a standard. And I think we're going to see a lot more of GraphQL in the future. So those are some reasons why you might want to use Apollo. Why might you not want to use Apollo? So one of the things with Apollo is that the reactivity model is based on polling. So if you really want reactive data, and it depends on your case, right? But if you really want reactive data and you want it to be fast, then Apollo is going to be harder than Meteor. But if you have a lot of users, then it's going to be hard to do it in Meteor anyway. And so there's a trade-off.
Polling cycles, you can configure them, right?
You can configure the polling cycle, yeah. So you can say how frequently you want it to poll. So you can probably get, but then if you're polling like every 300 milliseconds or something, that's not a very nice way to do near real-time data. Meteor somehow is more or less reactive. So polling is something you don't get. and that's the extent of the not to reason. But I had more slides that maybe I will come back to because they're hopefully later in the presentation. So that's a little bit about why, like, the kind of pros and cons, if you like. I mean, the other thing to say in the why not is Apollo is not production ready at all. Like, if you think Meteor is not production ready, forget about Apollo. They're still working on it. There's no guarantee the APIs are not going to change. It's very much in flux. Some of the stuff I spoke about may not be implemented yet. Some of the stuff they want to do is definitely not implemented yet. They want to do, for example, like WebSocket-based reactivity. So some of these things will be some of these holes will be closed, but they're not today. So it's definitely like on the bleeding edge. And that may be a compelling reason not to use it, depending on your circumstances. So what's the pitch for Apollo? So interesting, we had at the end of the conference, we had this kind of open panel session, and we had one of the employees from MDG who was there, and we were talking a bit about Apollo and where things are going and the whole thing, and he kind of gave this interesting pitch about his impression of what Meteor is about and that whole thing. And essentially it centers around developer experience. And his argument is that Meteor has always been about developer experience. They've always been trying to build the best way to build JavaScript applications from a developer's perspective. And so from that angle, his argument is that Apollo is MDG's attempt to build the best GraphQL developer experience that's out there, right? So the argument is that it's easier to use than something like Relay from Facebook, for example. Yeah, and so I haven't personally gotten into it, so I can't say whether this is accurate or not. But that's the pitch. If you read the marketing on the tin, the idea is you get the best GraphQL developer experience. So the other part about the future, Apollo is the future of Meteor. Apollo is going to be in Meteor. Like, Meteor is migrating to Apollo at some point. So they're building Apollo. Essentially, Yuri talked about, like, what does Meteor do and what does it do well? And part of that is the data layer. If you look at the different pieces, originally the MDG built Blaze, right, which is a pretty kind of big achievement. At the same time, it doesn't compete with React. And so they're starting to kind of refocus a little bit on what does Meteor really do well? And their argument is it's the data layer. So the current data layer in Meteor is going away and will be replaced by Apollo. Actually, the is going away part I assumed from the fact that Apollo will become the standard, but maybe they'll coexist for a while. But Apollo is the future of Meteor's data layer, which somehow begs the question, does it make sense to switch now? Right? Like, you're starting out with a Meteor application, do you want to use Meteor? There's also some integration between Apollo and Meteor, so you can use Meteor's authentication and have it very easily plugged into Apollo. Because Apollo, for example, does not natively, or authentication is something you have to handle, right? It's not just done for you the way it is with Meteor. But if you use the two together, you can do those things. And this is a question that there was a lot of discussion about in some of the Apollo sessions at the conference. A lot of people saying, should I be using this today? Should I start refactoring now? And I think that the strongest answer is always, what is it that you need, right? Do you need something that Apollo does or that Meteor does not have today? And my advice is always try to make your decisions based on that. Like, it's like the scalability problem. Don't solve problems you don't have. Like, I meet a lot of people. So so speed. The big thing is about speed of development, right? And how fast you can move. So we as a company at Superlumen, our goal is to take our clients from idea to launch in the shortest possible time. Right, so we typically work for startups, but we also we've done some stuff with Vodafone and race teams and this and that. And it's all about speed of execution, right? And so that's like one aspect of this whole developer experience and so on, is that you can move very quickly with Meteor. But as I mentioned in the introduction, there's also like an acceleration in the way that we are making software, right? The way that software is built, the rate of change is increasing over time. You know, we had Blaze, we moved to React, we moved to Redux, and now we're getting into stuff like Apollo, and there's a whole bunch of new change coming. So to answer the question about whether you should be switching now, our fundamental philosophy at Superlumen, and my advice to anybody who I have this conversation with, is just build something now. Get it done, right? And if you can do it with Meteor and you're familiar with Meteor, then do it with Meteor. If you are not familiar with Meteor, if you're just starting out and you're beginning this journey, and some of the things that Apollo does appeal to what you're trying to do and fit better, then maybe it's worth looking at Apollo. There are people building with it. It's in production. They're building it, I think, with a church group in the US. So there is a production kind of example. So in some way it does work, but it's definitely not like 1.0 release ready yet. So my strongest advice is always get it done now and do whatever you need to do, because the pace of change is getting faster, right? Like if you're thinking, oh, I'm going to wait for Apollo because that's the better stack or that's the right stack or something like that, it ain't going to happen. It's not going to come, right? Like by the time it's the right stack, something else has come out. By the time you're just getting your head around React, then suddenly you have to start learning Redux, because you know the pace of change is increasing all the time, and waiting for stuff to happen, in our experience, is a very bad plan. So build something now. This is our catchphrase, if you like. And just because I can, and I did this many times at the conference, I'm going to talk a little bit about reactivity, and because this is one of the main considerations if you're switching to Apollo for Meteor. You get reactivity for free in Meteor. You don't really get reactivity in Apollo. You can do polling, and it will do that for you and so on, but it's not quite the same thing. And so while we're talking about the future and so on, Apache Samza. Apache Samza is a very interesting concept, if you like, it's developed originally out of LinkedIn. And there's a great talk called Turning the Database Inside Out by Martin Kleppmann. And now there's even like a transcribed version, so you can read it faster. I'll put the URL up a little bit later as well. For my money, this is the future of reactivity. The talk is interesting, but the concept is, in my mind, like moving from Blaze to React. It's the same thing that we're going to do with databases. So for my money, this approach is the future of databases in general, specifically reactivity. And therefore, I think hedging your bets on Mongo versus Apollo and so on is a slightly short-term question, because I think we're moving to streams. So Apache Samza is all about streams, and it's essentially the idea of, there's a whole kind of presentation around it, and I'll just show you a couple of slides from the talk, and the URL where they come from is at the bottom. This is the traditional approach. You know, the browser talks to the back end, and then the database is where you store the state, the global state, and there's a whole bunch of stuff that goes on in this back end and so on. And essentially the proposal, if you skip through the whole thing, is that we move to a stream event log, right? So it's a little bit, this is very similar to the principles of Redux in the way that actions work. So if you're familiar with Redux, your writes become actions. And there's a lot of kind of smart thinking around this about what is a database? Is it an immutable, is it a shared state system, or is it a history of events and stuff? And so the whole concept here is to essentially turn the database around, and instead of thinking about storing data, which is ultimately a representation of something, instead store the instructions that were used to build that data. That's like one way to look at it, right? This is how Google Docs works, for example. So if you're editing a document at the same time as somebody else is editing it, there are no conflicts, because as long as you're editing different parts, because Google is storing like a set of operations that says go to line X and insert a character Y. And it's also how Git works, for example. Like Git uses the same approach. When you check out some code, Git does not consider that file as a single picture, right, or as an image of that file. It considers that file to be the result of a number of changes from an empty file in the beginning, right? And so this whole idea I think is going to change. It's going to change the whole way that we build applications, specifically connected applications, anything online. So this is like another slide where essentially you have these event streams, and then these three buckets are dependent on what views you want from the data. So he talks about materialized views, and essentially the idea is like, maybe for example, you have a list of blog posts, and so in comments you throw events into there, and then you want to know, like you want to have a database that you can query with all of your posts. And so this guy at the bottom listens for posts, and every time a post is inserted or updated or modified, updates his local store and has a list of all the posts up until the last event that was received. And then different clients connect to these different things, and maybe you have comments in a different node. And there's some really interesting stuff about this, because what you actually store is the log of events. So for example, if you're storing posts and comments, and then you want to add something like, how many comments does each post have? There's always this thing of denormalization, and you start, if you try to do this in Mongo, it's non-trivial, right? It's not a trivial task. Like you end up having to use these hooks and hoping that those hooks are always applied and that it's reliable and all this stuff, and it's, or recalculating or caching or these different things. And with this model, what you do is you just change the logic that was used to build the view, and then you rerun the entire event queue, right? Because you have the entire history. And also you can do stuff like, your metrics and so on, like a history of what happened. It's all part of the same system. You just have a list of events and they're time-stamped. Bottom line is, for my money, streams of the future. I think that we're going to move to, like, there's databases like RethinkDB, which are doing stuff with reactivity. I think that they will be eclipsed by these kind of stream processing systems instead of what we use today as databases. So that was a small indulgence about the future, and that brings us to the end of the presentation. Any questions on any of the above? Shoot.
You mentioned Apollo might replace the data layer in Meteor. Can you briefly explain how the data layer in Meteor works right now?
Okay, so the question is, how does the current Meteor data layer work in contrast to Apollo? So currently, Meteor's data layer is publish and subscribe functions. And so in the easiest form, you take let's say you have a blog posts, so you create a publish function, and maybe it accepts one parameter, and that parameter might be count, and you say count must be a number, and then on the client you call meteor.subscribe, and you pass the name of the publication and the count. So you say subscribe, I want 10 posts, and then your publish function gets called with the parameter 10, and the simple thing is it does like posts.find limit 10, and then it returns that cursor, and then Meteor handles making sure that if that cursor changes, then the updates get shipped to the client. So you don't really have to deal with it. It has some interesting like side effects, properties, whatever, in the sense that all of your data, because your collection names are global, all of your data ends up in the same place on the client. So on the client, you have one place that stores a list of all your blog posts, which is simple, right? I subscribe to 10, I get 10. But then if you have like a sidebar, for example, that shows you like most popular blog posts this month, that might be a different subscription, which is called popular posts. But those posts end up in the same client-side collection. So now you subscribe to 3 most popular posts and 10 posts on the homepage, and if there are actually only 11 posts between those, because 2 of them are then you have 11 posts in your local collection. And so there's some weird stuff there where you have to like have the same logic in your publish function on your client, because you don't get a specific response from the publish function. The publish function just pushes data into a central store of data on the client, and then you retrieve from that central store of data on the client.
So is it also stored on the client?
So it's not, so all data is not always on the client, but your publish functions decide what data gets pushed to the client. But if that data is from, if you have multiple publish functions with the same underlying collection, then those collections get merged on the client. Also for stuff like, what fields do you have available? So maybe you publish the post, but all you publish is the title, the author, and the body field. But then when you're actually editing a post, you maybe publish a whole bunch of other data that comes with it. That data ends up in the same client-side collection as your list of posts from the homepage. And so this creates weird problems and weird challenges where you think I can just iterate and display all my posts on the homepage. And then you add the sidebar that displays 3 featured posts, and suddenly those featured posts are showing up on your homepage. And you don't, and there's all these weird edge cases and stuff that's a bit hard to reason about, which is solved by GraphQL, not so much by Apollo is just an implementation of GraphQL, because you specify precisely what you want, and that's exactly what you get back. So it simplifies that whole system. Any other questions?
Actually, I have the impression with Apollo I can forget subscription publishing completely. Disappeared.
Yeah, so there's no publish subscribe with Apollo. Actually, there's no publish subscribe with GraphQL. So GraphQL has a different model where you build these queries and you specify the specific format of the data that you want, and that's what you get back.
Coexistence substitutes that completely.
So it's not about. You can use both Meteor's data paradigm and Apollo at the same time in the same application, and there are some packages that make that easier for your authentication and stuff. But you can't use it for the same data. So you can't publish some data on. You probably could, but you're asking for trouble. Also, because you're gonna have 2 copies of the same data and everything. Apollo uses Redux under the hood, so it puts all its data into a central Redux store, which has some nice benefits.
So, kind of expressing my Apollo ignorance here, but so what's the deal with methods? Because obviously the simulation part is not important anymore, but I need some way to communicate with the server. I need a way to say, I want to write this, or I want to do this sequence of that.
So the question is, what happens to Meteor methods? So methods essentially become mutations. So that's the way that the GraphQL way of modifying data on the server, or modifying state, let's say. I guess there are cases when you can use methods in a way that might not make sense to use mutations, because if you're not just mutating data, then I don't think that there is a means of doing that in Apollo. It does not have an equivalent. So for anyone who's not familiar with Meteor methods, the Meteor method is a way that you can define something on the server. You say, a simple method would be square. So take a number and return it square. You can define that on the server, and then you can call it on the client, and Meteor handles taking whatever data you pass to that function, serializing it. Meteor has its own serialization that they call extended JSON, eJSON. So it can serialize things like dates, which JSON can't. So even classes, you can add your own classes. You can do all kinds of weird stuff. Serializes all of that, ships it over the wire to the server, runs the function on the server, in this case just computes the square number, returns that value back, pushes it back down the wire to the client, and then the callback gets triggered on the client. And it's really nice when you want to. It's like kind of remote procedure calls or something, right? You can very easily just have something run on the server, have some operation performed, and get the result back on the client. And to the best of my knowledge, there's no comparable system in Apollo. Yeah. I also think mostly methods now are used for actual mutations where you want to change data, and that's handled by mutations of GraphQL. And the rest are probably weird edge cases, I think. From our experience, there isn't that much that we want to do on the server where we will actually want to specifically trigger a function call. You can also probably get around it with some kind of mutation or something, but yeah. Norbert.
How does Apollo address not authentication but authorization? Is there some sort of access control list that you run or anything?
How does Apollo handle authorization? authorization, authentication. I don't know. Simple answer. You mean, I'm always fuzzy on the difference between the two. Like, not specifically proving who the user is, but proving is the user allowed to do this?
Yeah, that's what I meant with the access control list. So to specify who
No.
is allowed to access.
So you build it all yourself. So there is no inbuilt, to the best of my knowledge, there's no inbuilt authentication or authorization in Apollo. There's a plugin that links it to Meteor's authentication system. So it does that by, it authenticates over DDP, creates a secure token, and then uses that token, adds it to the requests that are sent to the GraphQL server, and then decodes it and verifies it on the server side. And so that work is all done for you if you still use Meteor and DDP. But otherwise, it's something you have to build yourself. I assume, there's stuff like JSON Web Tokens, and I assume that there's also, because it's all just now, it's much more like closer to the Node community, I assume there are NPM packages that solve this problem that you can hopefully fairly easily use within the context of Apollo server, because it's much closer to traditional Node on the server than Meteor's magic around publication, subscriptions, and so on. Any other questions? Awesome. Great. Thanks for coming.